Okay, thank you for today. Welcome to the YouTube channel, my YouTube channel. Today I want to discuss about the transformer, the step-up transformer and the step-down transformer. That is the main electricity in Form 4 in Kenya syllabus. The question says, a hydroelectric power station produces 500 kilowatts at a voltage of 10 kilovolts. The voltage is then stepped up to 150 kilovolts and the power is transmitted through the cables of resistance 200 ohms to a step down transformer in a substation. Assume that both transformers are 100% efficient. Calculate number one, the current produced by generator. So the power, the generator is 500 kilowatts. That is the power station generator, hydroelectric power generator. The voltage is 10 kilovolts. Now the power is calculated by the formula P is equal to the product of voltage and current. Now, to get the current produced by the generator, you divide everything by V. So the current I is equal to P over V, of which the power is 500,000 kilowatts, and the voltage in that generator is 10,000 kilovolts. So this is equivalent to 500,000, that is 500 kilowatts, 500,000 watts over 10,000 volts. So in this case, I get my current produced by the generator is equivalent to 50 amperes. So this one is equivalent to 50 amperes. Now in this case, the voltage is then stepped up. A transformer that steps up voltage is called a step-up transformer. Now in this case, the voltage in primary is less than the voltage in secondary. Then because the number of primary turns is less than the number of secondary turns, so we apply the formula. Because the power is transmitted to the cables of resistance 200 ohms, the efficiency of the transformer is 100%. Now it means that the power input is the same as the power output, i.e. the power in primary coil is the same as the power in the secondary coil. Now this power, which is equal to the primary coil power, is the same as the one in the secondary coil, is as a result of the 100% efficiency. Now we say the power input is the same as the power output. Power input is equal to the power output. This is equivalent to 500,000 because that is the same as the power input. 500,000 watts. Now because you have the power input and the voltage in the secondary coil, we can get the current. We can calculate the current in the secondary coil because the power in the secondary coil is 500,000. Now to apply the P is equal to VI formula, so we say power is equal to VI. Now in this case, to calculate the current, we divide everything by V. So equivalent to current is equal to the power, which is 500,000, divided by the voltage. The voltage in the secondary coil is 150,000 volts. So in this case, this is watts, this is volts. And the current in the secondary coil, is the same as the current that is flowing through the transmission cable because the transmission cable is connected with the secondary coil of the transformer. Now this current is equivalent to 3.333 amperes. So we have 3.333 amperes. Now we can see that the current produced by generator is the same as the current that is on the primary coil of the transformer. This current in the secondary coil, the current is reduced. Now the work of the transformer is to step up or the step down of the voltage. Now when the primary coil voltage is less than the secondary coil voltage, it means that now the vice versa. The primary coil current is more than the secondary coil current. And then we go to part C, the voltage drop across the transmission cable. Now, how do we calculate the voltage drop across the transmission cable? The current in the secondary coil is the current that is flowing through the transmission cable. Now, given the resistance of the transmission cable to be 200 ohms and the current in the transmission cable is 3.333 amperes, we can get the voltage drop using the Ohm's law. Now, we apply the Ohm's law, we say V is equal to IR. So the current through the secondary coil is 3.333 multiplied by the resistance of the resistance of the cables, which is 200 ohms. So this one you get 666.6 voltage. Now this is the voltage in the transmission cable, 666.6 voltage. Then part D, the power loss during transmission. Power loss during transmission. Now the power which is lost during transmission is the power loss in the transmission cables. So the power loss is the same as VI, the voltage in the transmission cable multiplied with the current through the transmission cable. The voltage drop in the transmission cable times the current through the transmission cable. The voltage drop from the transmission cable is 666.6 volts. Then you multiply by the current in the transmission cable, which is 3.333 ampere. The power loss in the transmission cable is 2221.8 watts. So this power loss is the same as 2221.8 watts. Now, that is the power lost by the transmission cable. To get the power that reaches the substations, it is equivalent to the power from the secondary coil of the transformer. Then you less the power that was lost through the transmission cable. Now, the power from the secondary coil was 500,000 watts. That is the power input, which is equal to the power output. It is so because the efficiency of this the efficiency of this transformer is 100%. Now, the power reached the substation is the same as the power output. The power output from the transformer minus the power loss during transmission. Power loss during transmission. So this is equivalent to the power output is 500,000 watts minus the power loss during transmission, which is 2221 watts. And your answer is 497,778.2 watts. So this is the power which reached the substation. Subscribe to my YouTube channel and click the notification bell. Thank you for your time.